Hello my students, how are you? Grade 4. Today we'll explain lesson number 3, topic 7, repeated reasoning. You can use repeated reasoning to organize the answer. You can also use commutative properties and intuitive to find the answer. Look at the question. A company sells wooden storage couples. Jane bought 24 cupcakes. She wants to arrange them in a rectangular array. What are all of the different ways Jane can arrange them using all of her cupcakes? Explain how you know you found them all. We can write the answer. Count all things here. We have 1, 2, 3, 4, and horizontal 1, 2, 3, horizontal 4, and vertical 1, 2, 3, 4, 5, 6. 4 times 6 is 24. And also you can count all things by right hand side. 24 divided by 2 is 12. We know 24 divided by 3 equals 8. And 24 divided by 4 equals 6. 24 divided by 5 equals 4 and the remainder 4. 24 divided by 6 equals 4. You can arrange about 2 rows of 12. You can arrange also because 3 times 8 equals 24. 3 rows of 8 or 8 rows of 3 or 4 rows of 6 because 4 times 6 is 24. We have 24 divided by 5 because 24 divided by 5 equals 4 and the remainder 4. Okay. Table 3 times 8 24, 4 times 6 24, 1 times 24 4. You can use multiplication to find pairs of 24 and Jane can put the cubes in 3, 8, 4, 6, 1 or 24 rows. Do you need to try all numbers from 1 to 24 to be sure you have all the factors pairs of 24? No. Simple answer, you only need to try numbers up to 6 because 6 is already used in 4 times 6 24. Or factors greater than or equal to 6 are paired with a smaller factor that has been found. How can you use repeated reasoning to find all factors for numbers? New City Park is opening. The gardener, look at here. The gardener needs to select 15 trees from nursery and line the trees in rectangular array. What are all the different ways the gardener can plant the trees? You can write 15 equivalent 3 times 5 or 1 times 15. Look at here, we have how many factors? 4 factors of 15. 4 factors already, paired 5, 3 times 5 and 5 times 3, and also 1 times 15. What about 24 factors of 24? 1 times 24, 2 times 12, 3 times 8, 4 times 6. The diagram here shows all the factors of 24. Use diagram to justify conclusion that when factor pairs start repeating, you have found all the factors of a number. Simple answer, the factor pairs start repeating when you reach the middle factor pairs in the diagram. In this example, 4 and 6 are the middle factor pairs for 24. The factor pairs repeated starting with 4 times 6 and 6 times 4, then 8 times 3 and so on until you reach the number itself and 1 again. Analyze. Miss Marple wanted to arrange the 20 desks in her classroom into rows with the same number of desks in each row. She wants at least 2, but not more than each row. What are the factor pairs of 20 and explain 20? We know 20 can divide it by itself, divided by 4, divided by 10. 1 times 10, 20, 2 times 10, 20, 4 times 5, 20. The simple answer start with 1 to find 1 and 20 try to find 2 and 10. 3 is not factor. Try 4 found 4 and 5 try 5 to find 5 and 4. Since 4 and 5 and 4 are the same factor pairs, there are no more pairs to find. Find the ways Miss Marbles can arrange desks. Simple answer, she can make 2 rows with 10 desks. Each row, 4 rows with 5 desks in each row. 5 rows with 4 desks in each row. Any other arrangement wouldn't have at least 2, but not more than 8 rows. Independent practice. Kevin invited 15 friends into his birthday party. It's played a game where everyone had to separate into groups. Each group had the same number of children. The game couldn't be played with all 16 children. In one group, each group had to have more than one child. List the factors of 16. We know 16 equal 1 times 16, 2 times 8, 4 times 4. They can form two groups of 8 and 4 groups of 4 and 8 groups of 2. Why does 16 have an odd number of factors? Because 16 can be divided by 4. We can divide it 4. 4 times 4 is 16. One factor has the same number here, so 4 pairs with itself. Then stop checking for a factor pairs when you find pairs that repeated. It's simple answer: when you find a factor pair that repeated, that means all the factors that are greater than and less than his factor pair have already been found. Okay, don't repeat the number when you found like 416. Don't tell me we have two factors. No, you must count all number, not repeat it. Next question: store display. Look at here. A bit store needs 3 display with the product showing. The boxes of kitty litter need to be stacked with the same number of boxes in each row. There needs to be at least 3 rows with at least 3 boxes in each row. What are all the ways the box or the boxes of kitty litter could be stacked? Number 50 fish blues here and 40 boxes of kitty litter and 88 bags. We can raise the factors of 50. 50 can divide by 5, divided by 10, divided by 2, divided by 25. We have 50 fish balls and 48 boxes of kitty and 88 bags food. It meaning 3 is the number of display, the minimum number of row, and the minimum number of boxes of kitty litter in each row. What are the factor pairs for 48? We know 1 times 48 equals 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8 also. What are all the ways the boxes of kitty litter can be stacked with at least 3 rows with at least 3 boxes in a row? We can write 3 rows or with 16 boxes in each row, 4 rows with 12 boxes in each row, 6 rows with 8 boxes in each row, and also 8 rows with 6, because 6 times 8 equals 48. 12 rows with 8. 12 times 4 equals 48. So we have 6 times 8, 3 times 16, and 16 times 3 also. You can repeat the answer or use commutative properties to find the result. Okay, understood? So that's the question about this. About all number product, give me 48.